Let us learn to configure VLANs in Cisco Packet Tracer. A VLAN is a logical grouping of network devices irrespective of their physical connections. The primary functionality of VLAN is to segment a single physical network into multiple logical networks. Network segmentation enhances network security, also improves network performance, and also reduces broadcast traffic um, within a network. For example, broadcast traffic will be transmitted to every device in the network. So if I wanted to send it to a subset of the devices in the network, I can create a VLAN and then send the data only to that subset of devices in a separate broadcast domain. So you can logically separate devices into multiple broadcast domains and then transmit data within a domain. So now, because you are transmitting data only to a subset of network devices, the overall network traffic can also be reduced. So the initial phase involves creating the network topology. Let us assume three Cisco Catalyst 2960 switches. So this is a 2960 switch. I need three of them. We will connect them in series. Then also let us connect a few end devices, PCs. I will connect two PCs to switch 1 and two other PCs to switch 2. Sorry, switch 3. Switch 2 acts as a bridge between switch 1 and switch 3. Okay, we will use the switch 2 for a different reason later. I will rename this switch 1 as S1, switch 2 as S2, and switch 3 as S3. So now we will connect these devices using copper straight through cable. I'll choose the fast Ethernet port on PC and then connect to an available fast Ethernet port on switch 1. Similarly, PC 1's fast Ethernet to switch 1's fast Ethernet. Then PC 2's fast Ethernet to switch 3's fast Ethernet, and PC 3's fast Ethernet to switch 3's fast Ethernet. Also, we'll connect the switches in series using the same copper straight through. I will choose the gigabit Ethernet here and then gigabit Ethernet here. Again, a gigabit Ethernet port to a gigabit Ethernet port. Okay. So we are done with the physical topology. Now let us create subnets. We will assume two subnets. The first subnet is with the following network address 192.168.10.0. So any device in this network should have the same network address as given in the subnet. The last octet is not for subnet ID, it is reserved for host ID. So this last octet can be unique across all PCs within a network, within a subnetwork. You can notice that the IP address is a collection of 4 octets separated with the dots, and the subnet mask is 255.255.255.0. So the first 24 bits are reserved for network address and the last 8 bits are reserved for host address. So let us create a topology as assumed. So I will create a text next to the PCs. I will write the IP addresses we will be using for those PCs. 192.168.10.10 for this PC and 192.168.20.10 for this PC. PC2 and PC0 are assumed to be in the same subnet. So I will give the same network address as that of PC0 but with a different host ID. So let us use 20. And PC3 and PC1 forms a different subnet. So their subnet IDs should match 192.168.20.20. So let us assign the IP addresses first. Desktop IP configuration 192.168.10.10 for PC0. Subnet mask appears automatically. And then let us use the first usable IP address in this network address as default gateway 192.168.10.1. Repeat the process for the remaining PCs. For PC1, click on desktop tab, IP configuration 192.168.20.10 and 192.168.20.1. For PC2, desktop IP configuration 192.168.10.20 and 192.168.10.1. For PC3, it is 192.168.20.20 and the default gateway is 192.168.20.1. So let us verify. For PC3 it is 192.168.20.20. For PC2 it is 192.168.10.20. For PC1 it is 192.168.20.10 and here it is 10.10. So now let us check the connectivity. Choose a simple PDU. Select PC0, PC1, switch to real time. The connectivity fails. Okay. So now let us choose a simple PDU. Select PC0 as the source, PC2 as the destination, and this is successful. Okay. So because PC0 and PC2 are on the same subnet, you can transmit data. But PC0 and PC1 are on different network, so connectivity is not allowed. Now let us configure VLANs on configuration begins at the command line interface of a switch. Access the CLI. Click on the switch S1. Then navigate to the CLI tab. Then type enable to transition from the user mode to the privileged mode. The prompt will change from right angular bracket to hash. Next, move to the global configuration mode using configure terminal. Now we create VLANs. So let us create a VLAN 10, name it as scope exit, then VLAN 20, name it as sense, and then exit. Repeat the process on the remaining two switches as well. So I'll select S2 on the CLI tab, enable configure terminal, VLAN 10, name it as CSC, exit, VLAN 20, name it as name it as sense, exit. We have to rename VLAN 10, so I will go back to VLAN 10 and then name it as scope. So you can go to the privileged mode and then check the VLANs, show VLAN brief. So you can see two VLANs are created with IDs 10 and 20 and named as scope and sense. Now create the same VLANs on S3. Go to the CLI tab, enable configure terminal, VLAN 10, name it as scope, exit, VLAN 20, name it as sense, exit. So now we configured VLAN 10 and 20 on all three switches. Next is to assign ports to these VLANs. So to assign ports to VLANs, navigate to the interface configuration mode for the specific port you wanted to assign on a device. For example, if you see, this is interface FA01 and this is FA02. So on switch 1, FA01 has to be on VLAN 10 and FA02 should be on VLAN 20. Same applies to the interfaces on S3. FA01 is on VLAN 10 and FA02 should be on VLAN 20. So I will go back to S1 and then move on to the interface configuration mode. Interface FA0/1. Configure the port as an access port with the command switch port mode access. Access mode allows data traffic belonging to the same VLAN on that interface. Okay. So now you have to tell the port to allow VLAN 10. So switch port access VLAN 10. Exit. So after exiting, you return to the global configuration mode and repeat the process for all the other ports. Now I will move on to interface FA02 then switch port mode as access, and then switch port access VLAN 20. Exit. Repeat the process on S3. Go to the specific interface, FA01, switch port mode access, switch port access VLAN 10, then interface FA0/2, switch port mode as access, switch port access VLAN 20. Okay. Next step is to configure the trunk ports. Trunk ports are essential for carrying traffic from multiple VLANs between the network devices. For example, links that may have to carry uh, data traffic belonging to multiple VLANs, for example, this and this, will have to be connected to an interface configured on the trunk mode. So let us see the interface G01 on both the devices, G02 on switch 2 and G01 on switch 3. So I'll go to switch 1, choose the interface 0/1, and then select the switch port mode as trunk. Now go to switch 2, configure terminal, and then select the interface G01, switch port mode as switch port mode as trunk, exit. Now go to the second interface, 0/2, switch port mode as trunk, and exit. On S3, G01 should be on the trunk mode. So interface 0/1, switch port mode trunk, exit. So now let the links come up. So what I have done is, on the central switch we configured both the interfaces to operate on trunk mode. On switch 1 and switch 3 we configured G01 on both the devices to operate on trunk mode. So now these links are configured to transmit data belonging to both the VLANs, VLAN 10, also VLAN 20. Next is to test the connectivity. You can see the VLAN configuration on the switches before you uh, test the connectivity. You can go to the global configuration mode and then say show VLAN brief. So you can say FA0, you can see FA01 is uh, configured to transmit data on VLAN 10 and FA02 is configured to transmit data on VLAN 20. For checking the trunk configuration, show interfaces trunk. So here you can see G01 on switch 1 is operating on trunk mode and is active. So now let us check the connectivity. Click PC0 and then try to ping 192.168.20.10. This should fail because 20.10 is on a different VLAN and 10.10 is on a different VLAN. See, the ping was unsuccessful. Now let us try to ping a device on the same subnet, the same VLAN. This is 10.10 and PC2 is 10.20. They are on the same broadcast domain. So let us test the connectivity on the same broadcast domain. You can see the devices are still able to talk to each other. Now to enable inter-VLAN connectivity, we may need a router. So I will select a router and then connect switch to one of the interfaces on switch 2 to the router. So let us choose a router, for example 1941. Let us rename this as R0. Use the same copper straight through to connect them. I'll use the gigabit Ethernet 0/0 on router 0 and FA01 on switch 2. So this link will also carry data traffic belonging to both VLANs. So the interfaces should be on the trunk mode. So first let us go to switch to the interface FA0/1 switch port mode trunk exit. For PCs in different VLANs to communicate, a router is needed. So the interface that is connected to the router's interface connecting the switch will be configured to have sub interfaces on it. So click on router 0. So let us not enter the default configuration mode. So no, enable configure terminal, and then the interface gigabit ethernet 0/0. That was the interface that is connected to switch to. Is it FA0 or G0? Okay, so gigabit ethernet 0/0. Next is to configure sub interfaces on this interface. Gigabit ethernet 0/1. So we have to configure the gigabit ethernet 0/0 sub interface 10. So it should be interface gigabit ethernet 0/0.10. Then encapsulation dot 1q 10. Next we assign an IP address to this interface, sub interface. So IP address 192.168.10.1, and the subnet mask 255.255.255.0. Now exit. Let us now configure the second sub interface on the same gigabit ethernet 0/0 with dot 20, and then encapsulation dot 1q 20. IP address 192.168.20.1/255.255.255.0. Exit. So now let us wait for the link to come up. I mean, you have to uh, set the interface as no shut. So interface gigabit ethernet 0/0 no shutdown. So you can see the interface and the sub interfaces are now up. Once the sub interfaces are up, you can start transmitting data between multiple VLANs. So now you can see the link is now up. So I'll go to PC0 command prompt and then test the connectivity from 10.10 to 10.20. Sorry, 10.20 is reachable because they are on the same VLAN. We'll test the connectivity from 10.10 to 20.10. The first packet may be lost because of timeout, but the subsequent packets will all reach the destination. So now PC0 is able to connect to PC1. Also, you can ping PC3 from PC0. PC3 is 20.20. So from 10.10 we are pinging 20.20. First packet may again be lost. Subsequent packets will reach the destination. So for inter-VLAN routing, communication between different VLANs can be enabled using a router. This is known as inter-VLAN routing. The router's physical interface connected to the switch must be configured with sub-interfaces. Each sub-interface is assigned an IP address and encapsulation .1q. This inter-VLAN communication requires a router configured for routing between different subnets. So the process is to access the router CLI and enter global configuration mode. Then create a logical subinterface for VLAN 10 by typing interface gigabit ethernet 0/0.10. For encapsulation, specify the VLAN encapsulation protocol with encapsulation.1q10 and then assign an IP address to that subinterface. For example, 192.168.10.1 with subnet mask 255.255.255.0. Repeat these steps for VLAN 20, creating gigabit ethernet 0/0.20. A ping attempt between a PC in VLAN 10 and a PC in VLAN 20 should now be successful as the router facilitates the routing between the two VLANs. So this has illustrated the complete process of VLAN configuration in Cisco Packet Tracer using a 3-switch topology. So the important points to realize are the importance of VLANs for network segmentation, and then the process of creating the network, assigning VLANs and ports, and then configuring ports to operate in access mode and trunk mode. For inter-switch connectivity and the function of a router in enabling the inter-VLAN communication. Okay, thank you.